All right, so we were working with the vectors in, so far we have seen the vectors only in one dimension. They could be represented in terms of three axes. How many of you are familiar with this? There could be three axes, correct? You probably have used two dimensions so far. But if we put x, y, and then there is a third axis, z axis, when you're talking about a point in space, the description of the location for the particles will be given by 3 points. Any point in space, if you connect it to origin, this point can be represented by a distance on x-axis, distance on y-axis, and the distance on z-axis. This point, instead of having 2 coordinates, this point will have 3 coordinates on it, x, y, and z. And the line we draw in order to represent that point in space is defined as vector. We went over this definition in last lecture too. This vector can be represented by a vector called R, position vector. Position vector is a vector which is representing a point in space. Now if it is only 2 dimension, then you will have only x and y. Okay, if you're talking about a plane, then it's only going to be x or y, x or z, or maybe y or z. But if it is in 3 dimension, a point in space, generally this can be represented as R vector. It will position this point in space from the origin. There must be a reference, correct? We all know that, right? If we change the location of the reference, this point will change its value too. This position vector can generally be given as, so here is, why did I put the vector sign on the top of R? Because it's a vector. Vector can be represented as, you could put an arrow on a letter, you could make it a boldface, right, or italic. The most convenient one is going to be putting an arrow on it. So I will always use arrow. I, y, j plus z, k. Now this one, this notation is probably new for you because I put few things in there which are not very familiar, where one is x is the length of the vector along x-axis, length of the vector along y-axis, length of the vector along z-axis. These are not new. This is same as this point. No difference. However, I have put these 3 in there. These are called, you see, but I'm putting a hat on them. These vectors, they do not have a vector sign on them. Instead, they have a hat on them. These are called unit vectors. Why do we call them unit vectors? Can you get some hint from the name? They represent, they have a length of unit. It has a unit length. It does not affect anything for the magnitude. If their magnitude is 1 or the length is 1, it will only represent the direction. Make sense? Unit vectors are the vectors which have magnitude 1. They only represent the direction I for x-axis, j for y-axis, k for z-axis. All right? This is the one which we will rarely used, but once the vectors are introduced, they are always introduced in 3 dimensions so that we can understand all 3 of them. I for x-axis, so this represents, so when you put I, that means you're telling us x units along x-axis, y units along y-axis, z units along z-axis. Okay, or I can write it in a more generalized form. For example, you have 2i, 3j, negative 4k. What does it mean? I represents how long this vector is along x-axis. So this is going to be 2 meter length, 2. This is going to be 3 along y-axis, and this is going to be negative 4. I can, unfortunately, on the board, it's a plane, I cannot put the third line, correct? It would be very difficult for me, but it's going to be below the axis. So if z-axis is above the board, negative z-axis is negative z-axis would be below the board, inside. Or I could say actually into the board. A better word, out of the board or into the board? Yes. Right now my surface is board, right? This, if I'm using this book as my reference axis, x here, y here, where is the z-axis going to be? Perpendicular to both of them, it's either going to be positive z-axis would be upward, or it's going to be downward, correct? These all 3 vectors, you know this so far, right? You are putting a third axis with it, which is perpendicular to both of them. This is a plane. When you add this, this is not a plane anymore, right? It's space. 3D. Make sense? So I'm not using this flat surface. I'm drawing everything on the board. For me, my surface is the board. This is my x-axis. This is my y-axis. My z-axis is going to be somewhere here, right? My negative z-axis would be into the board, correct? Right? This vector is going to be, so if I, instead of this, if I put this is my third axis. Make sense? It's hard to visualize it, but in physics, there is a lot of visualization. Sometimes we can see things very clearly, sometimes it's not that easy to see. But this is the way to represent the vector, and this is a notation you will see when we will work with the vectors. And there are some rules which apply to this notation. Do you all get that? Good? Move on? Okay. So that was the representation of the vector in 3 dimensions. It is represented as a position vector, and I showed you how the position vector is represented. There is one thing I would like to add in the previous description. This vector r has a length, correct? How long it is? What is its magnitude? This length has a name. It's called magnitude. This magnitude is given by square y square plus z square. Okay? Magnitude is represented as 2 lines around the vector. Whatever vector you are using, you are using A vector, you will put A there, B vector, you will put B there. You're just going to put these lines around it. All right? Square root of each value along each axis, squaring them, adding them, then square rooting them. That will give you the magnitude of the vector. All right? Can you guess, if you are working with a plane, what is this magnitude going to be? If it's just x, y axis. If it's just 2D. Would there be a z? No. This is just going to be x and x square plus y square. Whatever is the value along x-axis, if I solve it. Here, you have 2i plus 3j a vector. You want to do the magnitude of this vector. 2 square, 3 square, 4 plus square root of 13. That is the magnitude of this vector. Make sense? All right. So when we say the vector in one dimension, what do we really mean by that? What do I mean by that? Am I only talking about the vector along x-axis? So there is, if it is in one dimension, that means it's either directed along x-axis or it's vertical. It's only in one dimension. All right? It's not in space. It's either directed along x-axis or it's directed along y-axis. This is not the vector you are talking about. That's in 2D. Right? If I put the arrow at some angle, like you said, that is the motion in 2 dimension. Why? Because it's moving, it's changing its x and y both. Right? But if it is moving, so if I roll this chalk this way, so it's only moving in one direction. If it goes straight, well, it didn't go straight. If it goes straight, it's only negative x-axis or positive x-axis. If I throw it up, it's only vertical axis. That motion is called motion in one dimension. That's where we start our kinematics, just with the one dimension, and then slowly add the second dimension to it. Now we were looking at this simple algebra for the vectors. It's not very complicated. That follows the same rules that you apply for any algebraic equation. As you see, for A, if there is a vector with a magnitude C 1.5, you see that vector is represented as arrowhead, and under it's without an arrowhead. That means it's showing the length of it or the magnitude. Magnitude is 1.5. Length is one thing and direction is the other thing. Don't confuse them with each other. Length is just a number. Magnitude is just a number. So if it is 1.5 long, if you want to get a vector which you give a new name as B and you multiply it by 2, it becomes 3.0, and that is going to be in the same direction. All it means is if you have a vector, you multiply it by a number, the size increases or decreases. So it's so if there is a vector A with 1.5, you multiply it by 2, 3.0. Now it's the same vector 2A, however, the length would be double. Will direction change? No. Why not? Because you are just doubling the length. When will the direction change? Can direction change? When you put negative sign with it. It's going to turn it around 180 degree. So everything will remain the same. The arrowhead will change. The tail will be on the other side and the head would move to the left. All right. So it is, I think, very, very convenient to make a link here. By changing the number, you are dealing with just the magnitude and the number. If you multiply a vector by a number, the magnitude increases or decreases. It does not increase or decrease. If there is a negative number, that means it's just going to change the direction. And on the B, if there are two vectors in the same direction, they just add up. Their magnitude just add up, and the direction remains the same. Here, If you have A and B vector, if they are in the same direction and you are doing A plus B, that is going to be very convenient. It's going to be 4.7 in the same direction, positive x-axis. However, if you are subtracting them, the way to subtract this and this, okay, pay attention to the words. The way you subtract two vectors, the one which is being subtracted, it needs to be inverted. Got it? So if A is here, B needs to be inverted. That means you multiply B by a negative number, which is negative 3.2, you subtract them, 1.7 is going to be magnitude. And that makes sense, right? If you have, for example, you have two things in opposite direction, one is going this way, one is going this way, they are going to cancel each other out, some part of it, right? Whatever is left is this one, right? If they both are in the same direction, if they are together, all together, they are going to add up. All right? So that's why when they are in the same direction, they add up. When they are in opposite direction, or when you are subtracting two vectors, they are going to be subtracted. Okay? But remember that method. That is, addition is quite simple. Subtraction could be a bit tricky because you have to take a negative of the vector which is being subtracted. Vector addition is cumulative. A plus B should be equal to B plus A. It doesn't matter how you put the vectors together. They are always going to generate the same answer. So if you have A plus B, okay. This is your final vector. If you are going this way, counterclockwise, A plus B, your final vector is this. But instead, you decide to put B first. All right? You put B first. This new vector, final vector, should still have the same length, same angle. Okay? As you can see, so when I'm not doing exact measurements, so that might look different from what I had before, but the intention was to draw the same length vector. So the location has moved. My A and B were down here, and now my B and A are up here because I have to put the B first, and B is making a larger angle. Okay? We have not done the head to tail rule yet. You just draw the pictures. Okay? Soon we will get there too. How do we add two vectors graphically? Vector addition is associative. A plus B plus C. It should be equal to A plus B plus C. And it is also distributive. If you have two constants, alpha and beta, they are not vectors. Okay, these are scalars, two numbers. When you multiply them with each other, they should be distributed. So if they are together, they will apply on A separately. Negative of the vector, we already went over it. Negative of the vector is nothing. You multiply -1 by a vector, and it just inverts the vector by 180 degrees. So if you're looking for A minus B, what you are actually doing is A plus minus B. All right? Okay, so yes?
When you were a couple months back, we were doing the subtraction and you had to study 1.5 minus 3.2, but it came out with a positive 1.7. Is that a vector property that is supposed to come back out positive, even though it's technically negative with subtraction?
So it was an absolute value. Okay, so the magnitude is always positive. The direction is what's going to tell you if it's going to be positive or negative. Okay, so when you find out the angle in positive x-axis or on negative x-axis, that is going to be related to direction. Magnitude is always positive. Okay, that's why you remember we were putting this around it. That is the absolute number. That is because it's just a number. Magnitude it has nothing to do. It will vary when you put the negative sign. If the vector is along the negative x-axis, yes, you are going to put a negative sign with it. Okay, so I will take you back. Question? Okay. I thought I saw your hand. A and B, if you are adding them, that's going to be A plus B. But if you are doing A minus B, what you got to do is minus B, and your final vector would be A minus B. Make sense? Right? You just inverted one vector. But you have to watch which one is being subtracted. If A is the one being subtracted, B minus A would be a different direction. Okay? Now I'm taking you, this is something I started my lecture with today, unit vector. So each vector can also be written as its magnitude multiplied by unit vector. The unit vector has magnitude 1 and only used for the direction. So if you have a vector only along x-axis, you see its magnitude is only with I, right? I is the direction unit vector which is showing that this is only along x-axis. If you have a vector only vertical, then it's going to be bj. What does b show? B shows the length or the magnitude of vector b. J shows the direction. Okay? If I put a negative here, what does that mean? If it's negative bj, it's downward. Correct? Did magnitude change? No. Did direction change? Yes. So negative, positive, they only show the direction. They do not tell you anything about the magnitude. Now with the background in vectors in one dimension, we are ready to work with the kinematics. Kinematics, does anyone remember the definition of kinematics I ever mentioned in class? Motion, right? Without the description of force. When we study the motion, without any description about the force, that where the motion coming from, or what is the possible reason of this motion. Like you don't talk about the forces at all and study the motion only. There you call this area or this study kinematics. Kinematics, we will study one-dimensional kinematics first, and we will slowly move on to 2D, something moving in space. We will study speeds, velocities, accelerations. We'll study the equation of motion for the objects moving at a constant acceleration. These are going to be main topics for this chapter. Same definition that I just went over, without considering the forces, we will study the motion, and motion can be described as positions, displacements, speed, velocities. Motion can be described in one dimension, like a car moving in one direction. Okay. Motion can be in 2 or 3 dimension, like a car going on a curve. Okay. So when you take an exit and you go on a curve, that is not a one-dimensional motion. One-dimensional motion when you are going straight. What are the quantity or the physical quantities that come to your mind when we are talking about the motion? What's the first thing? When something is moving, what is changing? Position, right? Or, and, not or, and, time, right? So if you are looking at the time, if I roll a ball and I start my watch and then it stops and I'm also looking at it and I stop my watch, I'm timing it too. Position and the time. The positions axis value at any point. This is the same definition that we already know for the position. Axis value at any point at a particular time with respect to the convenient frame of reference. Okay. What is a frame of reference? Frame of reference is the coordinate axis, right? That we always use in order to represent any pointing graph. Do we really need the frame of reference? If I'm standing out here and then there is a bus moving, all the passengers are sitting on it, and this is moving with 25 meters per second. All passengers are at rest with respect to the moving bus. Everything is moving with the same speed. If I'm standing outside and I'm looking at this person right here, what speed observation will I make? Is it rest with respect to me? Yes? Yes. But is it at rest with respect to me? Is he moving with respect to me? Yes. At what speed? 25 meters per second. Is that right? But if this person is making the observation, what observation will he make about his speed? 0. See, because they both are moving with the same speed, he's going to say he's at rest. Right? Now, this is one observer, this is another observer. Who is right? Both. Right? So, the only difference which is there is the frame of reference. The frame of reference is moving here. It's a bus moving at 25 meters per second. So, if you use the frame of reference as bus, your observation will change. If you take the frame of reference as me, who is at rest outside, standing on the earth, then the observation will change. But nobody is wrong. You always have to describe which frame of reference you are making your observation with respect to. Okay, you change your frame of reference, observation or result should change. Okay, so what we do in physics, we always keep our frame of reference at rest, which is Earth. Okay, we make all the observation when we talk about me running here, or when we talk about the car moving on the road, we are talking about the stationary frame of reference, which is Earth. Okay, and we know it's not stationary, but it's moving very slowly. That is going to make a very small difference to the observation. So these frame of references, they are important because relative to the frame of reference or the coordinate axis, your observation can have different values. We are always going to take any object as a particle. Okay, when we talk about the car, we're going to call it a particle. Particle, don't think that you're going to make your car like a very small thing. You are just considering it's like a compact object. Okay, it has a center of mass to it. And basically you are looking at the motion of that center of mass. It has a mass, but its size is really small. So particle model will always be used to describe all the objects. Displacement is the change in position of the object. If the object has moved from one position, which is xi, to another position, which is xf. I am using for initial, f I am using for final. Okay, so if it has moved from, this one has naught instead, initial position, x naught to xf. So if it has moved from x naught to xf, delta x would be the displacement, and you can see all these points, they have a vector on them. Okay, they are showing the direction. In fact, the first one, xf, is a position vector. X naught is also a position vector. You subtract them and you will get the value for delta x. This delta x is called displacement. Displacement is a vector quantity. It is always directed from the initial position to the final position. These are the spiral staircase. You take the stairs, you go up, you cover a distance of 5 meters, and then you take a slide and you have reached this point. That's our reference. You can take it as 0. So initially, this is our origin, or you could say like a reference line at origin, and the object started from here. You have a box, and you have pulled the box all the way up here. Could you tell me what's the displacement for this block? How much it has displaced? Sorry? I missed that. 5 meters, is that correct? All agree? What's the initial position? 0. What's the final position? 5 meters. Does it matter which path it takes? It doesn't matter at all. Shorter path and the longer path. Its displacement initial position is here. Vertically, it has only gone from here to here. So its total displacement going to be 5 meter. All right. What's the unit for displacement? Meters. It was a tricky question. So the professor has gone from 1.5 meter to 3.5 meter. So the total displacement would be 2 meter relative to the earth, right? Because when you're making the, if you are looking at this position with respect to the rest frame of reference, this position, and then you can subtract them and get the total displacement. The arrow represents the initial position to the final position. The displacement, can it be negative? Yes, if you are moving in the opposite direction, right? So if the person who was sitting on the seat and he has gone back by 4 meter, by covering the 4 meter distance, so he was at 6 meter and he has gone back to 2 meter, so the total displacement is going to be negative 4.0 meter. Conventionally, we will take all the distances along positive x-axis as positive distances. Everything along in the left side would be the negative displacement. Everything upward is going to be positive. Everything downward is going to be negative. Okay. So if I drop this book right here and my reference is this, it's going to be a negative distance. On the other hand, distance could be same as displacement or it could be different depending on how far the object has gone. Distance traveled is the total length of the path traveled between two positions. Distance has no direction, it has no sign. It's always going to be a number. Okay, no positive and negative. Positive represents either the positive x-axis or the positive y-axis. Negative shows either the negative x-axis or negative y-axis. If it is in the straight line, distance and displacement must be the same. Okay, but if the object is not moving in the straight line, they could be very different. We are going to see a problem related to it soon. The differences between them, distance is a scalar quantity because it does not involve any direction. Displacement is a vector quantity. Distance only requires the magnitude. Displacement requires the magnitude and the direction. Distance can be equal or greater than displacement. Displacement is always the shortest distance between 2 points. Both have the units of meter. Now this is what I started the lecture today. We're going to need two things, positions and the time. All the time passed or elapsed time can be defined as the final time. So it's like you start your clock and you stop your clock. So your initial time is going to be T0 or your final time is going to be TF. You subtract them and that is going to give you the duration of the event. Okay, you don't take just initial time or the final time as a final number. You would have to subtract them to get the change in time. You are looking for the interval. So if you started 9:50, that is going to be elapsed time and that is what we are going to use. If I want to know how much my acceleration or my speed changed during my motion in the class time, that would be over the period of 50 minutes. Initial time, most of the time you can set it as 0, right? Because it's under our control. If we set it as 0, whatever time you see on the clock, that is going to be your overall time. Starting with the definition of average velocity. Okay, it's not the speed, it's the velocity. Average velocity is the displacement, change in position, but that change in position is not the distance covered. It is the displacement. Displacement over time, total time passed. It's called average velocity. There is no way we could do the velocity at one instant. We call it the instantaneous velocity. However, if you are doing the average velocity, you have to wait for a certain time so that it can cover some distance, and then you can get the average velocity. Delta x is the change in position or displacement. Xf and xi are the final and the initial position at time tf and t naught respectively. If the starting time t naught is taken to be 0, then the average velocity simply is delta t, delta x over delta t. Okay, this is displacement, this is total time passed, this is the average velocity, this is a vector. Vector being divided by a scalar gives you a vector. Okay, so velocity is a vector quantity because it depends on a vector quantity. Okay, if displacement is a vector, velocity is also a vector. What's the unit for velocity? Can you tell just by looking at it? Meter per second. Very good. Okay, a little bit more description. It takes you back to the previous slide where the passenger went back on the plane by -4 meter. Because his displacement was towards the back of the plane, it is -4. If it took 5 seconds to cover that distance, the total average velocity over that period will be -4 meter over 5 seconds, and that would be -0.8 meter per second. Very small a very small velocity for that interval only. It really depends where you are taking your interval. Okay, you make your interval smaller, larger, that will change your velocity accordingly. Graphical description. Now this is just one curve of one motion. All right, it's like something is speeding up from A to B, then it changes its direction, and then it starts to change its speed, it starts to slow down, and then it speeds up in the same direction. So these are different points, A, B, C, D, E, F. You can take average velocity for all of them, right? You can take average velocity from A to B. You can take average velocity from B to C, C to D, D to E, E to F. Or you could do velocity from A to the final position, A to F. What you have to do is you have to draw a line from the initial position to the final position. When you draw a line, what do we call it? A slope, right? The slope, in this picture, it's not doing from A to F, it's doing from A to B. Blue line is the line representing the average velocity. You connect these points, delta x. So the physical meaning, I'm just going to write a line here. The physical meaning of position, slope from position versus time graph is average velocity. You take any 2 points on that graph and find the slope. That slope gives you the average velocity. that average velocity is subject to change if it is not moving with the same velocity throughout. Okay, if it is changing its velocity, like everywhere you see average velocity positive, B to C it's negative, C to D it's higher and it's negative again, from D to E it's going to be negative again, but higher number, and it will change from E to F too. All right. I'm going to stop here and we'll start with the average speed in next lecture. Oh, instantaneous velocity.